Okay, we've looked at how to solve equations when they're in exponential form by changing them to logarithm form. So for example, if we saw an equation like this, we've talked about the fact that we could rewrite this in logarithm form to figure out what x equals. Well, there's another method that we could use to solve for x in this situation, and that's what we're going to learn about today, and it's called taking the logarithm of both sides. Now, in order to do that, what we're going to do here is what's highlighted. It says you take the logarithm of both sides. That's the first step. After doing that, we're going to apply the logarithm of a power theorem. The logarithm of a power theorem, remember, that's one of the theorems we learned about in the last lesson that says if I had a situation like this, where we have the log of 2 cubed, that's the same as 3 times the log of 2, because this exponent we can park in front of the logarithm. That's the logarithm of a power theorem. So that's what they're referring to there, that we're going to apply after we take the log of both sides. Now the key thing too is to know if we ever have an equation where when it's in exponential form, it's got a base of e, we're going to use the natural logarithm of both sides. So let's look at an example. Make sure you write down this example in your notes because this is one that you'll see in your assignment. You could see on a quiz or a test. Now what I have highlighted is the way that would be phrased in a test question, because I would not give you the formula. It says, at what rate of interest compounded continuously do you have to invest your money so that it will double in 12 years? Again, I would not give you the formula, so you need to recognize the fact that when it says compounding or compounding continuously, that's when we use that formula for PERT, principal times e to the r times t as your exponent. Well, the only number that we have is that it's going to double in 12 years. So you might think that, well, we only have 12 as the only, I know that my time is 12, but we don't know anything else. Well, we do know that our principal is going to double. We want to figure out what our rate would have to be for our principal to double. Well, a represents the amount after a certain amount of time. So in this case, a is going to represent twice your principal. And then it would be r times your exponent of 12, or 12r. Well, if I divide both sides by p, I get 2 equals e to the 12r as your exponent. Now, at this point, there's two ways that we could solve this. We could use logarithms like we did earlier in the chapter or last couple of sections, or we could use this new method, which I'm going to show you. And that's to take the logarithm of both sides, or if the base is already in e, we're going to take the natural log of both sides. And then we apply that logarithm of a power theorem. So I'm going to take that 12r and park it in front of the natural log. Oops. And you may recall that the natural log of e, remember natural log means you have a base e. So if I have a logarithm of base e of e, well, that simplifies to be 1, because what exponent would you apply to e to get e as your answer? It's going to be 1. So really, we don't, that natural log of e, since it's 1, it's not really going to apply at all. It's not going to have any impact on the solution. So I would have the natural log of 2 equals 12 times r. So to find out what r is, I'm going to divide both sides by 12. And that would give me my answer of, like we said, we take the natural log of 2 divided by 12, and that gives you 0.0578. Which as a percent would be about 5.8%. So in order to double in 12 years, she would need to invest at 5.8%. Now let's look at the other method, just that way you can compare the two methods. We still would have to get the e by itself, so we want to get the, wherever the exponent is, you want that base to be by itself. So that part wouldn't change, but as far as how to simplify this, the other method, so we could go this way or this way, would be to write this in logarithm form. So it would be the log, your base would be e of 2 equals 12r. Remember, log base e is the same as the natural log, so we could say it's the natural log of 2 equals 12r. So to figure out what r is, we divide both sides by 12. And if you notice, when you do that, you get the same answer as what we had before, 0.0578, or that'd be 5.8%. So either method you choose, it doesn't matter. Personally, I prefer the second method that I just did, in green. But if you don't have a CAS calculator, or if you have a hard time writing things in logarithm form, using the method that I did in red at the beginning there would be the better of the two. So why don't you guys use either method to try out lesson 1, or try out example 1b here. So why don't you write this down, pause the video, and hit play when you're ready to check your answer. Okay, for this one, it says that we want to figure out what we'd have to invest it at, what rate we'd have to invest it at to triple in 20 years. That means your principal would be 3 times the original amount after 20 years. Or if you divide by p on both sides, the p's are going to cancel out, so we'd have 3 equals e to the 20 times r as your exponent. Again, you could use this method that we just learned about by taking the natural log of both sides. So the natural log of 3 equals the natural log of e to the 20 times r. I'll park that 20r in front. The natural log of e is just 1, so divide by 20, in which case we get r as being 0.0549 or 5.5%. If you'd done the other method, by changing this to be in logarithm form, we'd say it's a log base e, which remember is the same as a natural log, of your value, which is 3, equals your exponent, which is 20r. Divide both sides by 20 to get the r by itself, and you'll see that you have the same answer. R equals, we'll just write it as 5.5%. So either method would end up giving you the same solution. So basically it's all a preference deal today. A lot of times based on what calculator you'll have, and you'll see why here in a minute. But let's look at a story problem. The second story problem is not in your book. If you want to see how to do the first story problem, you can follow through the steps that you'll find in your book for this section. But let's look at this one. It says an archaeologist finds remains of an ancient wood cooking fire, determines that it has lost about 23.2% of the carbon-14 expected for that kind of wood. Well, recall that the half-life of carbon-14 is about 5,730 years. So this equation here that's kind of blurred out, I rewrote in purple here. So it says a radioactive decay model for this situation is given, where C is the original amount of carbon-14 and A is the amount present after T years. Use the model to estimate the age of the wood. Okay, so first off, we know that it's lost 23.2% of the original carbon-14. So that means that if we had 100% originally, and we lost 23.2%, that means 76.8% is present after a certain amount of time. Or as a decimal, that would be 0.768. And C is your initial amount. So we're going to assume that we started out with all of our carbon-14. So 100% of it, which as a decimal is 1.0, or just 1, times e to the negative natural log of 2, divided by 5,730. And we're trying to find the time here. Trying to figure out how long it would get down to 76.8% of the original amount. So again, this 1 is going to have no influence on our answer here, because 1 times e would just be e. Or if I divide both sides by 1 here, it would remain the same. So the 1 has no influence, so we'll just cross that out. Now here's where we have two choices. If you want to take the natural log of both sides, you could do that, or you could rewrite this to be in logarithm form, which is what I'll do this time around. So to rewrite this in logarithm form would be the log base e, or the natural log, of 0.768 equals your exponent, which is the opposite of the natural log of 2, divided by 5,730 times t. And if I wanted to get rid of the, if I want to get the t by itself, I would take the reciprocal of both sides, or the reciprocal of the negative natural log of 2 over 5,730. The natural logs canceled out, the 5,730 cancels out, so I'm left with on the right side t. And I'm going to multiply by, 5,730 divided by the negative natural log of 2. So why don't you guys go ahead, well, if you plug that, I'll just tell you, if you plug that in your calculator for your answer, you're going to end up getting, well, we'll just round it to 2,182 years. This is how old that fire would have been, or that wood would have been. For a problem like this, they just want you to see what your answer would be if you took the common logarithm of each side versus the natural logarithm of both sides. So for this one, we take the log of 7 to the x power equals a log of 28. Remember, I would take and write this as x times a log of 7 equals a log of 28. Divide both sides by the log of 7. And when you do that on your calculator, you're going to end up getting 1.712 as your answer. Now the interesting thing is this. If I were to take the natural log of both sides, that's part B. Well, you started out the same. Put that x in front of the natural log. Divide both sides by the natural log of 7. And when you do that, you end up getting the same exact answer, 1.712. So in other words, at the beginning, it doesn't matter if you take the log of both sides or the natural log of both sides. You'll end up with the same solution. The last thing we're going to talk about is the change of base theorem. This is very important. Now, a lot of you guys might have a CAS calculator where when you type in the log, you can change a base on your own. But a lot of calculators do not have that feature. If you're using your cell phone or if you're using any other scientific calculator as your calculator of choice, then you're not going to be able to change the base because the CAS calculator is one of the only calculators that will do so. So we need to have some way to be able to simplify one of these problems, like log of base 5 of 18 or log base 4 of 24. We have to use some method to be able to get your answer here. So that's where this change of base theorem comes in. All this states is that you just take the logarithm of whatever a is divided by the logarithm of b, and you get your answer. So log base 5 of 18, if I had to do that on my calculator that wasn't a CAS, I would just say it's log of 18 divided by the log of 5, and I ended up doing that on my calculator. Now, some of you guys might be wondering or saying, well, I don't need to know this because I have a CAS calculator. Well, sometimes it'll happen where you'll show up for a test and you won't have your CAS calculator. Maybe you forgot it at home, maybe it's out of batteries, or maybe just something's not working right on it, or maybe you're taking a test where you can't use your CAS calculator at all. So that's why it's so important to make sure you know this change of base theorem. It's really simple to remember. You just take the log of the value, log of 18, divided by the log of the base. Because your calculator, your scientific calculator, will only do common logarithms and natural logarithms. So when you type this on your calculator, you get 1.796. So on the day of a test, if you show up without your CAS calculator and you don't know how to simplify one of these, I'm not going to teach you how to do it on your scientific calculator. You need to know how to do that on your own. So a problem like this one, you just set it up like this, a log of 24 divided by the log of 4. And when you type that into your calculator, you end up getting 2.292 as your answer. So we're going to stop there. So hopefully you have an understanding of this other method to be able to solve equations where you have your variable that's an exponent. But it's up to your choice, unless your assignment specifically states to use the method of taking the logarithm of both sides. You can use any method of your choosing. Or if you have a problem like this that we just did on your homework assignment, you can just plug that in your calculator if you have a CAS. But if you don't have a CAS, you have to use the change of base theorem. So with that, good luck on your assignment.